Okay, here's the problem. First one from the examples. And just to make sure that you remember what this means, it's the summation, so adding up a bunch of terms. There's no number on top. Instead, just on bottom, it has j1 plus j2 plus j3 equals 7, which means for any three numbers, j1, j2, and j3, that add up to 7, we're going to add a term on to the summation. Now, one thing that sometimes they leave out is the fact that all these numbers are assumed to be non-negative. So, you could say ji is greater than or equal to 0 for all of these. And that's usually a given for these kind of problems, that we don't want negative numbers in there. Because then there would be an infinite summation, which wouldn't work out. So then this is a summation of 7 factorial over all three of those numbers, whatever they are, each time, factorial. And that's a multi-permutation. And it's also, you can see it as 7 choose j1, and then out of the remaining choose j2, and out of the remaining choose j3, which is exactly what we're looking for in a multinomial. Because if you have 7 parenthesized statements all multiplied together, and then you have to multiply everything by everything, so to get a particular like term, you can choose j1 of them to contribute one of the items, j2 of them to contribute the next item, and j3 to contribute the last. And then we see what the items are. There's 2 to the j1, 3 to the j2, and then the secret to this is that sometimes it'll be multiplied by 1, and so compare this to what I have on the paper, 1 to the j3. That's not written on the paper because it doesn't need to be. 1 to anything is 1, so it just is assumed. But you need to know that it's there so that you can make it match the formula. Then we can say that this is equal to 2 plus 3 plus 1 all to the 7th. That's exactly where that formula comes from, above there. And so now we can simplify it. It's 6 to the 7. As the final answer, which you can work out on a calculator. I'll just leave it as that. The next one is similar. It says, find the coefficient of x squared y to the 5 in x plus 2y minus 3 to the 9. So, they're saying that that's the multinomial now, x plus 2y minus 3, all to the 9th power. And they want us to figure out what the coefficient of x squared y to the 5 would be. Well, if you get good at this, you can do some of the work in your head. But for now, let's write x plus 2y minus 3 to the 9 using the multinomial theorem. So this is going exactly the backwards from the previous problem. Previous problem, they gave us the summation. You have to recognize it and write down the multinomial. Now here's the multinomial to the power 9, and we want to use the theorem. So it is very similar in that there are 3 items added together inside the multinomial. So again, it will be, oops, I'll make that prettier, j1 plus j2 plus j3 equals 9. 9 is the power on there. And so inside it will be again 9 factorial. 9 and 9 have to match. And j1 factorial, j2 factorial, j3 factorial, want to know what those j's are in order to get the coefficient. Well, then I see where they came from. They're going to be the powers on this. But I'll go ahead and finish it out. There's going to be an x to the j1, 2y to the j2. Notice that that 2y is the second piece inside of the multinomial. It has to stay together, so it's all to the j2. And so also same thing for the minus 3. The original multinomial all has pluses, so this will be a minus 3 in parentheses to the j3. All right, now we can start thinking about it, because they want to know the coefficient of x squared y to the 5. Now, finish this question here a little bit. They want to know what that coefficient is. Well, that means I know right away that j1 is equal to 2 and j2 is equal to 5. All these like terms have been collected in this theorem, in this summation. So there's no other places where 2 and 5 can show up as j1 and j2. And then now I also know what j3 must be, because they have to total to 9. So therefore j3 has to also be a 2, so that they add up to 9. 2 plus 5 gives you 7, but that's not enough. We need it to add up to a total of 9. All right, now I know j1, j2, and j3, so I can find the coefficient by just filling them in. But it still is going to be some work to do, because I'm going to fill them in here underneath the 9 factorial. And I'm also going to fill them in here. Right? Well, x squared is going to be part of the problem. Y to the 5 will be part of the problem, but 2 to the 5 is going to show up, because the 5 will have to go in the 2. And also I'll have 2 on the negative 3. But now we should be able to do it just by looking. So the answer, the coefficient, is equal to, here, let me draw it over here, 9 factorial, the 3 numbers, 2 factorial, 5 factorial, and 2 factorial. And then I don't want to forget these extra numbers that came from the original terms in the multinomial. There's going to be a 2 to the j2, which is 2 to the 5. And also a negative 3 to the 2. Now it's time for the calculator to finish that off. But that's the full written out version of it.